All right, so today we're going to continue our discussion about solving fractional equations. And the most important thing to take away from today is when am I allowed to cross multiply and when am I not? Is this one of those problems where you're allowed to cross multiply? Don't yell out. Yes or no? What do you think, Edgar? And what do you think, Ivan? Yeah, it is. It's definitely one of those problems that you're allowed to cross multiply because you can just put a 1 underneath the 5 and then you can circle it up, right? You get 3x times 1 equals 5 times 4. 3x equals 20. Now what do we do from here? What do we do from here? What's up, Vanessa? Yeah, we're going to divide both sides by 3. Divide both sides by 3, and then you get x equals 20 divided by 3. That's totally fine. You don't have to get a whole number. Yeah, 20 divided by 3 is totally a fine answer. There's nothing wrong with it. Don't think you're wrong. This happens all the time. What's up? That's it. Cross multiply, that's all. So, let's take a look at this problem right here. Is this a problem where we can cross multiply, yes or no? Yeah, because there's imaginary 1. Alex, you are so smart, buddy. Yep, definitely. So here we go. So we'll cross multiply now. Yeah, there you go. It's just 3x times 1 equals 4 times 5x minus 2. It's going to stay 3x on the left. Yep. Whoa, I don't know what. Hold on one second. Maybe. We got to distribute this 4. 20x minus 2, right? Good. You guys are so smart. Yeah, make sure that you double distribute. Make sure. Oh, that's the mistake most people make all the time. It has nothing to do with you being good or bad at math. Just make it rain. Now from here is going to be an interesting question. We're trying to figure out how much plus what? How come? Yeah. We're trying to get the x's together. We could have plus 8, Ivan. It would have been an extra step. Yep. What are you thinking? Yep, you're dividing by this number that's next to the x so we can get x by itself. You guys are so smart. Close. What's a negative divided by a negative? Good. Nice. You guys are so great. Way to go. Yep, that's it. That's the answer. 8 over 17. Is 8 over 17, is that more than 1 or less than 1? Good. Ah, I like it. I like it. You don't even have to put the imaginary 1 underneath the x. But we can if you really want to. Yeah? We can. Let's put it there. Now, what is the least common multiple? The first thing you kind of want to do is circle all these numbers in the bottom. What's the least common multiple of 5, 4, and 1? 1. Nope. You're thinking of factors. Think higher. What's the smallest number they all evenly divide into? 20. Very nice. The LCM equals 20. The least common multiple. When you hear that word multiple, think higher. Factor, think smaller. So, we're going to multiply everything through by 20 over 1. It's a secret technique. It's like math jitsu. You know what I'm talking about? Yeah. Oh, because you look at the bottoms. Yeah. Yeah, you look at the bottoms. Only the bottoms, right? I'm going to show you another way to tackle these problems. In fact, if you get confused, you don't even have to put that 1 there. Is this better? Is that easier to see? Okay. Okay. Oh, you want me to put the 1 here? Okay, all right. If you really want to. Now we're going to distribute in. You get 20x plus 40 over 5 equals 60 over 4. Let's talk about a common mistake. Common mistake. Everybody always wants to do this. But you know the problem with that is that you have another quantity out over here. You can't cross multiply unless it's just two fractions, and only two fractions set equal to each other. That's why I'm putting these problems next to one another. So you cannot do that. Let's go back for a minute. What you can do is, here's 20x. What's 40 divided by 5? Very nice. This is the magic part. What's 60 divided by 4? No, close. Very nice. 60 divided by 4 is 15. You guys are so good. So good. What do we do from here? Minus 8. Minus 8. Yeah, there you go. You get 20x. No, close. No, 7. Yeah. Divide both sides by 20. We're still trying to get x by itself. We're almost there. Almost there. And there we go. X equals 7 over 20. We're going to do that same problem just one other way so you can see that there's two ways to solve the same one. Ready? Okay. Suppose you didn't know the math jitsu move of multiplying by the least common multiple, right? Suppose you had no idea how to multiply by, that you could multiply by 20, it would clear. How else could you solve this problem? How else? Sulema? No, no multiplying. All you're going to do is talk about fractions, right? Here's what you're going to do. You're going to subtract 2/5 from both sides. I'll show you. Don't worry. Subtract 2/5 from both sides. You get x equals 3/4 minus 2/5. Now, you can only add or subtract two fractions when they have the same what? Denominator. The denominator is which one of the numbers, the one in the top or the one in the bottom? The one in the bottom. And so what is the common denominator for this kind of fraction? It'd be 20. Multiply this one by 4 over 4. Multiply this one by 5 over 5. And you get that x equals 15 over 20 minus 8 over 20. Right? What's 15 over 20 minus 8 over 20? Ooh, you guys are amazing. X equals 7 over 20. That was the same answer we got before, right? Nice. I like it. Let's compare them. Let's compare them. Two different ways, totally amazing ways to get the same answer. I don't know. It depends. Maybe less work, but harder ideas. Whatever way you want to use, though. I like this way, personally. I like multiplying through by a number and watching them all vanish. Plus, my old math teacher used to call it a terminator, and he used to make weird sounds, so it makes me remember all the funny things he'd say. Yeah, terminate. He would say, the denominator, and he would, like, tell to the fractions. Yeah, it was funny. So here we go. Here's a fraction. Can you cross multiply, yes or no? You cannot cross multiply. So what are we gonna do? How are we gonna solve it? We are going to. You can put the 4 over 1. Is that what you like to do? All right. Now, what is the least common multiple? The LCM of all of these numbers. Quince. It is quince. Yeah, it's 15. We're going to distribute that inside. We're going to distribute that inside. You ready? You're going to get 15x minus 45 over 5 plus, yeah, we are doing math jitsu, 60x over 3 equals 60. We're going to reduce now. We're going to reduce. How many times does 5 go into itself? How about 45? No. 9. Very nice. How about 15? 3. They all were reduced by 5, so that this becomes 3x minus 9 plus. What's 60 divided by 3? 20. There you go. No? Right? 3 goes into itself once and 60 20 times. Yep, that's how it works. Now let's take a look at this. Let's take a look at our next part, right? What do? We need to tighten up this side. We need to tighten up this side. Jordan, what are you thinking, buddy? This quantity over here, is there anything we can do to it? Close. Take a look. No, not. Tighten it up. Tighten it up. Combine like terms. This and this are the same. They're on the same side. Let's make that 23x. Minus 9 equals 60. No way. No way. Plus 9. You know what we're looking for in the end, Elizabeth, is we're looking for x to equal only one number. Okay? So 23x equals 69. Good. Very nice. Yeah, divide both sides by 23. X equals 69 divided by 23. Last and final problem of the day. Take a look at what's on the board. We're going to use our math jitsu technique, right? Yeah, we are multiplying through by 6. Eric, you are excellent at this, buddy. 6 over 1. We're going to distribute that inside. Where did I get 6 from? Take a look at the 2, the 3, and the 1 in the bottom, right? Only the denominators. You're looking for the least common multiple, the smallest number that all the denominators evenly divide into. So that's where I got that 6 from. Let's multiply it in. You get 6w minus 18 over 2 minus w plus, whoops, I made a mistake. It should have been 6w plus 30 over 3 equals negative 12. Now here's what you need to watch out for. I want you to take a look at something. You see this problem right here? What's the main difference between this problem and the one behind it? What's the main difference? One is an addition problem and one's a subtraction problem. Take a look again. We're not even done yet. Do you see how one is an addition problem and one is a subtraction problem? Which one do you think is the harder one? Nope. Why? Let's take a look at why subtraction is more difficult, right? Let's reduce these fractions down. What is the first one reduced down by? Reduces down by, everything gets reduced by 2. 2 goes into itself once, 9, and this becomes a 3. So it becomes 3w minus 9. And I'm going to put that in parentheses because, you see the subtraction? You see it? Let's reduce this one down. Put it in parentheses. Now let's go back. Now let's go back to this for a minute, right? Take a look at the difference. When you have an addition symbol, do you have to distribute the addition symbol inside and change the signs? No, but the subtraction symbol comes with an extra added step. If you have a subtraction symbol here and you have a polynomial, a many-termed item, you have to distribute this subtraction symbol inside to each one of the terms. That's what makes these more complicated. Lots of people lose a stupid point there. So it becomes minus 2w minus 10 equals negative 12. Yeah, because when you remove the parentheses once you distribute, and then as Eric suggested, now we're going to tighten things up. It's going to be 1w minus 19 equals negative 12. Now how do we get that w by itself? What are we going to do? Yes, we are. We're going to add 19 to both sides. Very good. Wow, I'm very impressed. 1w equals 7. By 1w is the same thing as me writing w. That's a good thing to remember.